Hi, everyone. Can you hear me okay? Good? Okay, so I'm Matthew Werner. I work with Ruby and Ember at a company called Zendesk in San Francisco. I drink a lot of coffee and whiskey, not always together, and I listen to a ton of music while I do all of those things. So today, I wanted to talk about the changing front-end ecosystem. It's been really rapidly changing over the past few years, so much so that we have a new term for it, the single-page app. And it's important we talk about this because it kind of changes the role that Ruby is playing in serving up websites. If you look like 5 years ago, Ruby is kind of proving itself to the public production environment. And you had sites like Twitter, GitHub that were trying to actually get serious scale with Ruby, and it accomplished that. And when they did that, they ended up pushing the expectations that these had for the functionality of those websites, and that functionality was taken care of by JavaScript. And you ended up with a JavaScript Renaissance, so much so that a lot of attention started going towards JavaScript, and people started treating it like it was the first thing to be taken care of. You had a lot of developers that started pushing investment into this, and you ended with a lot more framework options to have this client-first development take place. However, this introduces new challenges because a lot of the stuff that JavaScript is taking care of is new challenges that Ruby has already handled. We've been around for a while handling big sites, and these JavaScript frameworks are trying to take care of things that are oftentimes already solved. So if we implement some Ruby to supplement this new stack, we can take care of a lot of stuff for them. I should clarify, this isn't a language war or anything like that. This isn't a conflict. It's a matter of using the right tool for the job. Great websites are going to require both Ruby and JavaScript, and the better you're able to integrate the two, the better your app is going to turn out. But languages working together can be kind of tricky. The Ruby stack is familiar, but this is a new pattern. A lot of the things that you're used to when you work with Ruby are not going to be quite the same, and you have to be flexible with that. So what you want to do is make sure that your solution works for your app in particular. Because you don't want to just stick with the common patterns are, and you don't want to go with what the SPA is supposed to be doing. Just work with what you need. So where does this leave Ruby? I mean, you kind of feel a little left out with this because this is all new JavaScript. And Ruby provides a lot of functionality, but there's a lot more to go. And you end up with this when we want something like this. So at Zendesk, we decided to back our app with Rails. And this is our interface. We have a single-page Ember app. And we used to serve it with just an index HTML, and this past year, we started backing it with Rails. We got a few benefits out of this, and really there is more benefits than I can cover in this conversation, but the three that I want to talk about is managing your servers and deployments, getting some better flexibility out of your app so you can take care of some edge cases better, and really the driving factor was data provisioning and performance. So we start with deployment. Let's assume that we're making a new app and we need to deploy it out to the servers. I'm guessing the majority of people here, if you raise your hand, have used CAPISTRANO before. This is a very common case. This is great for a Rails stack, really easy. You just include these require statements and you get one line and it deploys very, very, very quickly. However, this doesn't really make sense for a single-page application. You aren't restarting unicorns. A lot of the requirements that your Rails stack has just don't make sense in a single-page app. So we ended up writing our own deploy script. Here you can see the top line is assets precompile, and that's the standard Sprockets asset pipeline rake task that you normally use, and that builds all the productions, takes care of minifying, fingerprinting, dependency mapping, all that kind of stuff. And then the second task, there's a precompile for deep deployment. And that's our own rake task. What we do is once we have those production assets, we evaluate what assets the names are, and we build something we call an asset manifest. looks a lot like this, where we iterate over the JavaScripts and the style sheets, and we know what those assets are called so that when we come to request time, we're able to accurately address these to the correct places. When the request comes in, we read this file off of disk, and we insert these script tags into script or link tags, respectively. And really, this ends up representing the current version of your application in production. So after we've done that, we upload all of our assets to the server, and then we use something we call a deploy verifier to make sure that the assets are where they need to be. And this is a nice benefit of working with a single page app because you're able to confirm that everything is right in the right place and it can be on live servers without actually making the switch over for your end users. In the deploy verifier, we go through and we check each of the files independently through the open internet, and we verify that the assets are available. When we kind of draw this out, it's really simple. You issue the command, and then you make the request through the internet to make sure that you assume the role of the client, because you might have some sort of internal network set up that you might be able to access the assets, but your clients, your users can't. And you have the added benefit of warming up the CDNs to retrieve those assets as well. This is especially useful when you're getting multiple CDNs serving up your assets for your production application. So once you get the 200 back, you know that your assets are readily available for your users, and you can continue with your CAPISTRANO task. You can see here, if that fails, we abort the deploy altogether. That way we know that whenever we make the switch on manifest.json, we know that those assets are going to be accessible to the end user, and that our application is going to start just fine. And then at the end, we finally upload our manifest. And when that file is on the production servers, the next request that comes into Rails, it grabs this file and reads the new fingerprinted assets and serves up the new assets for the end user, effectively bumping the version for the end user. And you'll notice this has nothing to do with unicorns. We're not uploading a bunch of Rails code and restarting the usage of that. We can pre-compile it locally, upload it, and go through this process, and it's distinguished between uploading your assets and actually making the switch independently. So after that, when we first started talking about backing with Rails, I was a big proponent of it, mainly because I like the idea of my application being flexible. I wanted to have like a lot of options to be able to do interesting things with Rails on the back end. Things like shelling out to other services, CDN failover, background jobs, or handling sensitive data. A lot of this kind of stuff is really difficult to tackle on the front end. And one of the things that we got out of this that I want to talk about today is better authentication strategy. Because on the front end, you have something like this where you request the index.html, it processes the application JavaScript, and then it needs to know whether or not you're authenticated to load the app. And that requires a separate request. You hit the API, it says that you're not logged in, and then you end up with a window location redirect to go to the login page. And it looks a little something like this. I'll give you the full effect, and we'll wait another second. And then you hit this. That's a terrible experience. You're essentially lying to the user, saying you're loading the app, when you're actually just checking to see if they're allowed to load the app. We can do this a lot better if we add a dynamic backend to it. These are all the things you're taking care of when you're booting that application. You're processing the DOM, you're processing application.js, a lot of these things that you don't need to be doing because you don't even know if you need to do them yet. You don't know if you're authenticated. If we look at this stack, which we're much more familiar with, you request the index.html from Rails. You can do the checks with the database. And if they're not authenticated, just 301 to have a transparent redirect over to the login page. This is a lot cleaner. It's much easier even. If you're using Devise, this is all it takes. This gets you much better performance. If we look at what we used to be doing, it effectively removes all those steps. You do one check with the database, and you don't have to be doing all this extra overhead, and it's a much better user experience in the end. So let's assume that we have taken care of that. We've got our app deployed. we've got a better user experience, and now we're actually hitting some traffic. And our application is starting to get a little bit slow because we are serving a lot of network requests, and we want to get better performance out of it. This is the normal situation where you just request an index HTML, and Nginx is able to return it without even hitting a Rails stack. This is great for a very simple case because this is a simple, fast request. You don't have the overhead of Rails. And it looks something like this. Just application CSS, application JS, very simple. So then if you add a little sophistication, we maybe have accounts now. We want to know that when we render the DOM. Then we want to know what user they are and whether or not they're a member of that account, like in the authentication example. And before long, you have a situation like this. This is us once. And that's only XHR. We had so many different requests to get tons of different data for different parts of the UI. And this adds up, obviously, just purely in network time. So if we add a Rails backend, we can even keep it the exact same way. You can add a Rails backend without changing any of the other stuff. You can get the other benefits, and you can still have your client be asking for all this other network calls. You're not helping the situation much, but it's really easy to ease your way into this. You could even make your backend server make these requests. Now, this doesn't make a whole lot of sense unless you don't have control over the API, because you're really just moving the problem from one place to another. What we really want to be doing is remove these network requests altogether. So what we did is we served our single page application from the same repo that had our database access, from the classes that like users' accounts, so that we can access the database directly and not go through a network. And this ended up being a great situation because now we don't have any network calls at all. We only have the Rails response that has the data in the index HTML, and we even went one step further and we were able to cache a lot of these requests. So that when we were, like, memberships doesn't change very often. So you can very easily cache that data in JSON format as you return it back to the user. We do this by piggybacking on the index HTML and putting the data into the DOM itself and consuming that in the single page app. So if we look at this HTML that we had originally, it looks something like this, where you just use the standard Rails fragment caching, and you insert a script tag with a preload type, and the ID has the URL that you would be hitting if you were requesting that data from the single page application. Then you just insert some HTML-safe JSON into that script tag, and you return the index HTML just like you would be doing normally. But now it has all this preloaded data inside of it, which is easily consumed by the client. This is what it ends up looking like when it's all rendered out. So then on the front end, a little bit of JavaScript. You iterate through all the scripts, and you grab them, and you move them into a hash that's keyed on the URL that you would be requesting. And you remove it from the DOM, which is important because you don't want subsequent requests to be getting stale data. Whenever you insert this in the DOM, it's good for one request. You have the single page application use it to get started, and then you delete it from the DOM so that it doesn't get used again. Once you have that preload hash built, what we do is we override the fetch request in Ember, where if they request a certain URL, we check that hash to see, is that URL keyed in our hash? If it is, use the data that we have there and return that instead of making a network call. And then we remove it from the hash to know that we've consumed it. If it's not there, make a normal request. So this allows us to preload network calls one by one and just work our way through it as we go and cut out more and more network requests. We can also make sure that we're not preloading too much or not enough data, because we can check the hash at the end of this whenever we're booting our application and see, is there any data left in here that we didn't end up using? Then we're preloading too much. Or are we making network calls during our boot cycle? Why don't we have it in this preload hash when we could be making a lot faster that way? And what we ended up doing after we implemented this, we saved 63% on our boot time, because we were able to go from saving all these network calls to inserting the same data that we would be returning into the DOM in the initial request. So the last thing that I think is a great thing about implementing Ruby into your single-page application is that you get to work with a great community of developers, potentially the greatest in history. And I have oftentimes been very happy that I found Ruby, because I used to be working in other languages and I didn't necessarily like it, and then I found Ruby and I love it. So I'm glad that I have an opportunity to work with that. So thank you very much, and hopefully we still have time for questions.
Thank you very much. And we have 15 minutes for questions.
I thought, all right, yeah.
Okay, Martin Durst, Aoyama Gakuin University. One thing that you explained is that you can save time by putting the data into the index.html page to avoid network requests. How would that change with HTTP 2.0?
Yeah, you can parallelize a lot better when you have HTTP 2, speedy. We did some tests with that, and it didn't help as much as we were hoping. We thought that there might be a lot of bottlenecking on Nginx, but we were hoping for like the 63% improvement, and we weren't getting anywhere near that. We were getting like maybe 18 or something. And that was a large factor in the decision to go aggressively with the preloads, because we didn't think that there was going to be as much help from Speedy as we thought there might be. But you know, I'll wait until we see it in full use.
Before you switched to a single-page application, what was Zendesk using, and was there then any challenges that you had from switching from presumably a traditional architecture to a single page?
Yeah, we actually still use the old one too. We've got some customers that prefer to use it, so we run that as well. And that was a Rails 2 application. And we had the benefit of having that existing when the new interface was made. And we were able to use a lot of the same classes and a lot of the same code from that repository in the new approach that we took. And the transition was generally okay. I think the agent interface, the second version, became a lot larger project than initially was expected. And when we were able to make the switch back to using Rails, it was facilitated well that we already had it available. I think it would have been much more difficult if we were writing a lot of those things from scratch.
I guess this morning there was also a bit discussion about turbo links and those kind of things. And I would love to hear your opinion about those kind of maybe more traditional, more Rails-based approaches versus Ember versus maybe even Angular. I don't know how much other stuff you evaluated and how you came up with the conclusion to use Ember.
Yeah, I think the decision was made quite a while ago, and I think it was mainly driven by responsiveness. A lot of what I was talking about of like the expectations that the user has to like have that really like front-end feel. And that kind of made turbo links not an option, especially if we use an MVC framework on the front end, you usually have that bundled with like handlebars or something like that. And you can't really work handlebars and turbo links together very well. I think they ended up making just the decision to go with a framework as it's meant to be delivered together rather than this amalgamation of different frameworks. And at the time that we actually made the decision to go with that, we weren't using Rails at all. Like, we were just serving up an index HTML because we liked the idea of it really being light. But once your application gets to a certain size, it's not feasible anymore, and you need to be able to do stuff like preloads.
Thank you for the talk. And I think I might have been a bit confused at the one of the slides earlier. When you eliminated the API, well, sort of took out all the multiple API calls you were making from the front end just directly to the API and took it within the Ruby app. I wasn't quite clear. You were connecting to the database, or were you sort of was introducing sort of another layer? It seemed like you might have been repeating code there and working around the API, but I thought maybe I just missed something.
Yeah, so I kind of thought about that when I was making this. If you're consuming a third-party API, you don't exactly have the same options we had. Like, we were consuming our own API. So we were able to move our index serving right into the API's repository. So then that allowed us to use those models and connect to the database directly, leveraging all the same stuff. Like I said, the old code, and using that when we're serving that initial index. If you don't have that option, this is a lot less appealing, obviously. But even then, you do have the option to do a lot heavier caching and multiplexing and those kinds of solutions that they're better. But if you have control over the API like we do, you definitely want to be moving into that same application to share that code and share those database connections.
じゃあ
Often when you hear the term single page application, then what actually happens is that in terms of address, in terms of URL, it's really just a single URL, and you can move around in that application and whatever. But then if you want to point your event to a specific, something like a bug or whatever is the application handles, there's no chance. Or let's say your browser shuts down, and you get up and start at the start or so.
Yeah.
Is there anything that you had to do, or what's the connection there? How can that be avoided?
We had a hashed-based URL for initially, and we recently switched to real URLs. And that required the little extra code on the back end where basically you used a wildcard route on the back end that all routed to the same template, and then we just moved these preloads into the layout. So you're able to pass that same URL, the full URL, that gets caught in the routes, goes to the controller, and renders the layout so that the single page app can boot. And then you need to modify the single page app to be able to handle real URLs rather than hashed URLs. So that can then route to the correct page. So if you click down into your application, you go to users number 10, and then you refresh the page, that request to the server goes to users/10, your wildcard route catches it, serves up the index HTML, and then your single page app routes users/10 again, so you end up in the exact same place. But it's mainly, I mean, the back-end work is way less work than the front-end work in that situation. You really just need a wildcard route and a controller that handles these things.
前
I was wondering if you did any kind of timing on the DOM side of things. I was referring to how you're creating HTML elements and then supposedly, well, for at least a part of the DOM to be loaded, and then extract all the JSON data and trash the DOM nodes that are not necessary anymore. So it's kind of like, you know, on the other side, putting some stress on the client side of things. So just, you know, interested in if you had any insight on that.
Yeah, it was considered, but in the grand scheme of the amount of thrashing you're doing when you're building the template from the single page app, this is inconsequential. The amount of time you're saving on a network call is going to be far greater than changing the DOM. And usually a lot of those fetches are happening really early in the boot process. So your DOM hasn't been all that built out at that point, and it's pretty simple to be modifying. And then once you consume those script tags, that's when a lot of the templating kicks in and you're able to build out the DOM.
Hey, can you share some numbers about the total number of servers you were using for the single page app and afterwards?
I don't think it really affected the servers. I think like we were a little bit worried that we could end up increasing a lot of load on the servers because we're now doing a Rails request rather than Nginx response. But we also thought that we'd balance that out by saving on the total network calls. I'm not as involved with the ops side of things, but from what I've heard, it's comparable. We didn't get any angry emails or anything, so it's fine.
Ah, 上の方に
Have you considered to use local storage as a cache for non-credential information instead of the caching the data inside the HTML file?
Local storage? Yeah, and we're still looking into that. We're still considering doing that sparingly. We're mostly concerned about keeping it in sync. You kind of open up a can of worms when you start getting into local storage because you're constantly trying to make sure that you're not using stale data. And that's why we were really aggressive about removing it from the DOM, because we wanted to make sure that we aren't like stepping between the source of truth and the client. And if we start, preloading data in the DOM and then keeping data in local storage, you start to get like several locations where you're trying to figure out which is the right one. And so we're looking into what cases are good options to do that, but we're doing it very tentatively.
あ、前の方に
Hi. How do you manage the JavaScript libraries like images? Do you use gem like backbone Rails, or use Rails assets.org, or just put them under vendor assets, or other ways?
We use the asset pipeline. We had been building all of these assets from Rails before we started backing it on each request. Just largely because of the fingerprinting, honestly. Sprockets gives us fingerprinting and most other build tools don't. So our deploy of those assets would be running a request through an asset pipeline, grabbing the assets that are built and then uploading them manually. But we were just leveraging the asset pipeline in order to handle those assets. And then we just upload them to the servers, they get served to CDNs, and it goes from there. As far as like libraries go, it's really just sprockets.
Are you using Ember data these days, or are you still using your own thing?
Still using your own thing. Yeah, the fetch change was, we just kind of imposed that right into the middle. And I don't know if you noticed, but the slide, we're actually like using straight up like Ajax rather than like some Ember call. And that's because we're still using Ember resource, the one that we had pre-Ember 1. So I don't really know if there's any plans there. I think like people lament about still using that, but it's a big change.
Okay. Okay. Thank you very much, Matthew.
Thank you.